So hello everyone, and welcome to MacDermid Enthone's discussion today on our TriMac Eclipse, which is a dark trivalent decorative sulfate-based chrome process. My name is Robert Collin. I'm the Americas Technical Manager and will be the moderator for this event. The presenter of the TriMac Eclipse, Chrissy Polera. She is our Decorative Business Development and Product Manager for Decorative Coatings. When you have questions, please submit them in the questions box, and we will answer them at the end of this session. If for some reason we cannot get to your question specifically, we will follow up with you via email. Again, thank you all for taking the time to learn about our TriMac Eclipse. Hope you are all being safe. And with that, Chrissy, the session is yours.
Thank you, Rob, and thank you everyone for joining me today as I talk to you about MacDermid Enthone's TriMac Eclipse Dark Trivalent Chromium process. So I wanted to give you some background first on Trivalent Chromium, some of the technologies that MacDermid Enthone has to offer, some of what we're seeing in the marketplace today, and then I will talk specifically about MacDermid Enthone's TriMac Eclipse process. We're seeing a lot of changes in terms of trivalent chromium. Much of that is based on legislation, and in the situation of dark trivalent chrome, on color needs. So from a standpoint of legislation, when we talk about the elimination of hexavalent chromium, a lot of that is being driven in Europe by REACH. We're seeing a lot of that in China right now as the government is starting to regulate some of these chemicals, such as chromium trioxide. We're also seeing a lot of regulation in the US right now with PFAS chemistry. So that does drive some of the change from hexavalent to trivalent chromium. Again, we talk about design and color. So when we're switching from a bright standpoint, from hexavalent to trivalent, color is definitely a driver. But the designers really have a strong influence on what colors are chosen, whether they're bright or dark. When we do this, when we introduce trivalent chromium, though, from an electroplating standpoint, it does open the option to other technologies such as lacquers, PVD, etc. We are utilizing our Eclipse process right now, actually, to replace or serve as an alternative to some of these dark PVD finishes. So we do open up the door for other technologies, and we're switching to some of these other finishes. But in all of these situations, both bright and dark trivalent chrome, there are OEMs that are currently running these processes or are in the process of approving them. And so we're providing samples on a regular basis for new colors and new callouts. Trivalent chromium has been in use for quite some time. When we talk about the replacement of hexavalent, the Europeans, again, were at the forefront of this, and they started to investigate substitutions as early as 2004. The French were really drove this. So Renault and PSA were the first to have trivalent chromium on their OEM specifications. But the dark finishes were absolutely driven by the Japanese. Our twilight finish, and I'll talk about all of the portfolio options that MacDermid Enthone offers for trivalent chromium, but twilight has been in use for over 20 years. So these are not new technologies. The Eclipse is the newest, but trivalent, and especially dark trivalent, has been in the marketplace for a very long time. A lot of what has made them last so long and become so viable, especially the darks, is that they are excellent when we talk about Russian mud protection or calcium chloride protection. And I'll talk about that requirement and that test as we get through this presentation. So when MacDermid Enthone is developing a new technology, there are a lot of attributes that need to be taken into consideration. Three main attributes that we're looking for out of a new technology or a new system are quality, styling, and environmental compliance. So obviously any system that is developed needs to either meet or exceed the current OEM specifications that are out there. And a lot of times, obviously, we're striving to meet automotive because they're typically the most stringent, but we will also, if there are other tests that are outside of automotive that we need to meet, we'll add those in as well to make sure that we're meeting the highest quality possible. Styling, as I indicated, is a big issue. We know that design drives a lot of these finishes, and we're able to produce a variety of colors with all of them. So if we talk about the Eclipse specifically, I can have a bright, dark finish with the Eclipse, but I can also add some level of texture, if you will, or mateness underneath that finish with a satin nickel deposit. So there really is a huge range when we're talking about the colors that are available and what they look like based on the nickel layers that I can incorporate underneath them. And again, environmental compliance is a big one, and we'll talk about sustainability in a second, but we understand that not only our business, but many of these industries are striving to be greener, or as many people say now, more blue from a chemical technology perspective. So while we're doing that, we also need to make sure that we're meeting these surface finishing requirements. Sustainability is something that we strive for, not only at MacDermid Enthone, but for our customers and throughout the supply chain. So we strive to develop technologies and processes that can help to reduce the environmental footprint and improve environmental compliance and sustainability. So we talk about making this process more sustainable. Does it last longer? Is it viable? How do we reduce the amount of water that is used? How do we reduce the amount of energy that is used for a process? How do we make it easier to waste treat these processes? So these are all things that are taken into account from a sustainability and an environmental standpoint when we talk about developing these technologies. And again, as I indicated, the philosophy at the OEM level is changing. We're talking about more blue strategies, more environmentally compliant processes throughout the supply chain. I've been at some OEMs recently that have implemented sustainability teams, that their sole responsibility is to work on implementing a sustainable process in the supply chain. So this is not, something that just MacDermid Enthone is aware of and working on. It's something that we're going to start to see, if you haven't already, throughout the industries and their supply chains. So obviously it's important to work on helping to meet these specifications, but also to implement and develop new alternative technologies that could help meet these needs. Trivalent Chromium being one of them. So I wanted to give an overview of the different options when it comes to Trivalent Chromium overall. There are two electrolytes, and this is not just MacDermid Enthone, but this is industry-wide. You can have either a chloride-based system or a sulfate-based system for Trivalent Chromium. The attributes that I have listed here are specifically for their bright trivalent chromes. That's where we see the most difference in those technologies. So a chloride-based system has a very limited thickness distribution. We'll see a lot of difference between high and low current density area. Because of that, typically add iron to those systems, and that will help even out the thickness distribution of that deposit. I have good Russian mud performance or calcium chloride protection with these systems. The cast performance is good. I will see some tendency to crack in the high current density area. And again, this is because that thickness distribution could be so different. If I'm trying to meet a thickness specification in a low current density area, I might tend to build up too much thickness in the high. And by too thick, I'm talking about maybe half a micron or more, as where I might see some tendency to crack. These sulfate systems, from a bright standpoint, they don't need iron unless we're talking about some very difficult and complex geometries, but typically their throwing power is sufficient on their own. I can achieve a color very close to hexavalent chrome, but because that system operates like hex chrome and is such a pure chrome deposit, my calcium chloride resistance is also similar to hexavalent chrome and is really not very good. but I do have superior cast and neutral salt spray performance, and I don't have that tendency to crack like I do with the Electrolyte system. So really, it's important to understand what the performance requirements are, what the color requirements are, in order to determine the most suitable process for every application. So McDermott Enthone's portfolio encompasses a variety of bright and dark finishes. We recommend post-treatment, and we have chromium-free options for all of these finishes. We can achieve colors that are similar to Hexavalent Chrome, while also achieving colors like TriMac Eclipse, which are very dark. We can achieve high cast and Russian mud, and all of these are OEM approved, and I'll talk about the approvals for Eclipse specifically towards the end of this, but as I indicated, Trivalent Chromium has been around for a long time. So Twilight has had approvals for many years, being the lightest of the dark finishes. And it really has allowed for Trivalent Chrome to penetrate the market. Because of the success of that technology, we were able to introduce not only other dark systems, but gain confidence in the bright trivalent systems and allow them to be utilized within the supply chain. McDermott Enthone is well established. We have many approvals with Trivalent Chrome, and these technologies are well known throughout the globe. Before we talk about each technology specifically, I think it's important to understand the C-Lab color scale because it's mentioned quite a bit and is used as a differentiator when we talk about each of these finishes. So as you see here, I have an L value scale, an A value scale, and a B value scale. So my L value is what determines the darkness or brightness of my finish. The L value can go from 0, which is very black, to 100, which is very white. As a benchmark for you right now, before I talk about each of the trivalent systems, Hexavalent Chrome has an L value of about 82 to 84. So pretty bright, pretty white when we think about what a hex finish looks like. We don't really talk about the A value all that much. It's something that's difficult for the regular consumer eye to see, but it is a measure of the green or red of a deposit. The higher that A value, the more red it appears. The lower the A value, the more green it appears. And lastly, we hear about B values quite a bit, and this is a measure of how blue or yellow a deposit is. The higher the B value, the more yellow, which is typically less desirable. The lower the B value, the more blue that deposit is, which is typically more desirable. So again, if I talk about Hexavalent Chromium as my benchmark, hex finishes typically have a B value of around 0 to negative 0.5. So we're striving, if I think about bright trivalent finishes, we're striving to meet that L value and that B value requirement. So these are the technologies that are part of McDermott Enthone's Trivalent Chromium portfolio. The two finishes on the top, my Trilite Flash SF and Trilite Flash CL, are the bright trivalent offerings, the SF being sulfate-based, the CL being chloride-based. And then the three on the bottom, the Twilight, the Starlight, and the TriMac Eclipse, are the dark trivalent finishes that we offer. All of them, as you will see, are sulfate-based systems. And we recommend sulfate because we have found that they are the most consistent from a processing standpoint, but also from a color standpoint, and they are the easiest for our customers to run. You see, if I talk about L values, going from Twilight to Starlight to Eclipse, those numbers get lower, which means those finishes become darker. So my L value for Twilight, anywhere from 64 to 69. Starlight, very close, 62 to 65, slightly darker than Twilight. And then a big jump when I talk about Eclipse with an L value of 43 to 46. One of the things that we also see typically with dark finishes is that as the L value gets lower, so if I compare Twilight to Eclipse, as I go from the 60s to the 40s, typically my B values will go up. I tend to get more yellow. And this is something that we continue to work on. It's something also that it is an industry. It's not just solely based on Twilight and Eclipse. We do see this throughout the offerings in the industry, that the darker these finishes get, the yellower they tend to be. But as I indicated earlier, excellent for rush and mud protection, very good corrosion performance. But one of the things that these technologies do, obviously, again, eliminates hexavalent chromium, eliminates PFAS from the plating process, allows for easier waste treatment and enhanced worker safety. I wanted to take a second to also mention the post-dips that are available and utilized with these processes. There are two that we recommend. One is cathodic, which is the Electropass 5. The other is anodic, which is the Trilite CP3000. And we utilize a post-dip with all of our trivalent finishes. We really recommend the use of them. If I think about what happens in a hexavalent system, based on the nature of that chemistry, as soon as a part comes out of a hex bath, it's going to oxidize on its own. It forms a passivate immediately after that plating process. Because of the nature of a trivalent system, it does not. So I can come out of that system, but it'll form an oxide or a passivate, but on its own, naturally, it'll take anywhere from 10 days to 2 weeks to do so. So we passivate these systems on their own within the plating process to ensure both superior cast and or neutral salt spray results. These post-dips do not change the color of the deposit, and they can be used on all substrates. So every industry, whether it's automotive, appliance, sanitary, has specific requirements, whether it's a color requirement or a performance requirement. So when we're developing these technologies, there are a wide variety of things that we need to keep in mind and test these finishes to in order to determine if they are viable for the industry. Color obviously is a big one. Cast, neutral salt spray, depending on whether it's just strictly automotive or maybe for sanitary as well, for building and hardware. Rush and mud is an automotive specification for exterior applications. And then things like wear resistance, cleaner resistance, etc. So all of these tests are taken into consideration and are tested to when we're developing a finish. I wanted to take a minute also to talk about the layer composition and how they influence this corrosion resistance and the color of the deposit. The final color that we see, whether it's bright or dark, is really driven by that chrome finish, that final layer. So if I have a bright trivalent finish, obviously that finish is going to be bright. If I have a dark finish like the Eclipse, that final finish is going to be darker or closer to black. It is also the chrome deposit that determines if my finish is appropriate for rush and mud corrosion or not. As I indicated, hexavalent does not do well for rush and mud, neither do my bright sulfate systems. But the dark finishes, the bright chloride systems are excellent for rush and mud or calcium chloride corrosion. So that performance characteristic is driven solely by the chrome layer. When I talk about some of my other corrosion tests, such as cast or neutral salt spray, those are driven by the nickel layers that are underneath the chrome. And we'll talk about how these nickel layers drive cast and drive the corrosion within each layer, depending on, and we add layers into the system depending on what that requirement is. But when we talk about corrosion, again, there's two forms, either driven by the nickel or the chrome deposit. So one of the challenges with trivalent chromium really is, we talk about color obviously, and that's a challenge depending on the system, but we need to either meet or exceed the specifications that are out there. And we've been able to do that in all cases. Some OEMs right now are mandating that the trivalent system meet the current requirement and have not changed their specifications, while other OEMs have developed specifications solely for trivalent chrome. Others have developed them solely for dark trivalent chrome. So it's important to understand at the OEM level if there is a difference in specification, and if so, what those differences are. Again, multi-layer nickel is important. It's important to understand which layers are required for that performance. And I also want to talk about implementing trivalent chromium into a line briefly, because this is becoming more and more popular and mainstream as applicators are starting to adopt these technologies and plate these different finishes. A lot of the question becomes, how do I implement this into my facility? A lot of people don't have the room to do that. And so that becomes an issue, and they have to install a whole new line. I will say a separate line is ideal to have trivalent all on its own, away from the hexavalent process. But if it needs to be done, trivalent chrome can be implemented into a hexavalent chromium line if all of the right precautions and guidelines are followed. So if that is a consideration, I would beg you to reach out to your local tech service team or to me and my team, and we can help you lay out that line and determine the best process for your facility. So this is what a typical cross section of a trivalent chrome plated part would look like. This is a plastic part, ABS, electroless nickel strike, followed by copper. Again, we're talking about an automotive spec here, so significant amount of copper on that part. Triple layer nickel utilized in this construction, so semi-bright, bright, and microporous. Again, as you know, if I think about the total construction, the amount of chrome that is on the top is so small compared to the rest. 0.2 to 0.3 microns typically is what is called out. And really the only difference, again, between this deposit and a hexavalent chrome finish is that final layer. It's just replaced with trivalent instead of hexavalent. When we look at a step chart, this is really what helps us determine where the corrosion is going to lie and how to optimize the corrosion, or the cast, I will say, how to optimize cast and neutral salt spray results for deposit. The more layers that I have, the better my performance. So if I talk about bright nickel, if I'm, let's just say a 40 micron deposit, which is pretty thick, but anywhere from 25 to 40, I can really only expect to get maybe a 24-hour cast out of that requirement, out of that deposit. As I introduce more layers, such as semi-bright, microporous, and high sulfur, I'm able to dramatically increase the cast performance. We can get up over 80 hours, in some cases 120, with the introduction of high sulfur. So adding in these layers helps with cast. It's also important that the millivolt potential is appropriate for each layer. If they all had the same millivolt potential, there would be no benefit in adding all 4 of these layers. So it's important that these differences in millivolt potential exist. There are requirements at the OEM level for what these potentials need to be, and they should be followed in order to obtain maximum corrosion protection for these parts. Just a little bit more about step briefly. If you look at this chart, my more active finishes are closer to the bottom. So high sulfur is the most active, followed by bright, and then microporous, and then semi-bright. And I really need those differences, as you can see, between high sulfur and bright, between bright and microporous, and then between bright and semi-bright. Those differences really help to control the corrosion to stay in specific layers to optimize my performance. So let's get into trivalent specifically and the TriMac Eclipse process in more detail. If I'm looking at a comparison just of hexavalent versus the TriMac Eclipse, the base for that hexavalent electrolyte is chromic acid. We already talked about the fact that all of the dark finishes that McDermid Enthone offers come from a sulfate electrolyte. The alloy for hexavalent chromium is pure, essentially, so only chromium, pretty much 100% chromium in that deposit. The TriMac Eclipse specifically has chrome, sulfur, some other elements alloyed in there as well. And as a result of that, the amount of chrome in that deposit is really only about 50%. So quite a bit different. But our dark finishes, we're seeing in the marketplace in any industry, these finishes continue to increase in popularity. I think you go back 15, 20 years, people thought it was going to be a phase, and really dark finishes have only continued to grow in every single market space. And this is really because, they provide an attractive finish, they give a more luxurious look, but they're able to meet the appearance and performance requirements that are set out for any supply chain. They have excellent covering and throwing power. I can achieve a consistent color from low to high current densities, and I have both outstanding CAS, neutral salt spray, as well as calcium chloride corrosion. So there's a lot of reasons that these technologies have been implemented and have lasted so long across the board. The Eclipse system specifically is sulfate based, again, with an L value of about 43 to 46 and a B value between 4.5 to 5. My typical plating speed for a 0.1 to 0.15 micron, my typical plating speed is 0.1 to 0.15 microns a minute. Typically, we'll see a 3-minute plating time, in some cases even less than that, to achieve the required deposit thickness, depending on the application. Again, though, excellent rust and mud protection and excellent cast performance. The operating parameters for this system, the chrome runs at a gram per liter level, or a concentration of 8 to 14, pH of 3 to 3.5, operating temperature typically 104 to 118. A lot of people are running around 109, 110 with this system. Current density of 50 to 120 amps per square foot, with an average plating time of 2 to 3 minutes. There are several components in the Eclipse system, and when I talk to plating facilities about Trivalent Chromium, and not just the Eclipse, but Trivalent Chromium in general, because this is typical of Trivalent Chromium systems, I encourage people to think about a Trivalent Chromium system like a nickel bath. So you have in a nickel system your brighteners, your levelers, your wetters. That's how I encourage people to think about a Trivalent system. It should be maintained like that when we're talking about surface tension, darkness of the deposit, if we're talking about Eclipse, for example. But it helps the line operators really to think about Trivalent Chrome more appropriately than just comparing it to a hexavalent system, because it runs very differently than hexavalent Chrome does. But you see here a variety of components, 8 to be exact, 1 powder, which is our conductivity salts, and the rest are liquids. So a chrome component, several darkening agents, an initial additive, a regulator, and a wetting agent. So all of these are utilized regularly in every system. We're able to analyze for each of them, except for the part E, which we continue to work on. But all of them are able to be analyzed either via titration or ICP, or in the case of the wetter, via surface tension analysis. Replenishment for each system, we do recommend automatic dosing for these components. Again, these are all the liquid components. So the chrome and one of my darkening agents is the most, or my initial, sorry, is the most, followed by those darkening agents. So it's important that these are all dosed at the recommended rate. These can be combined, so you don't need 6 feeders. Most of our customers are running either 2 or 3 to replenish these systems. You don't need to have a separate dosing system for each component. So troubleshooting a little bit, I'll talk about some of the typical issues that we might encounter with a TriMac Eclipse bath, and what you might expect to look for and optimize in order to optimize that performance. Wholesale is obviously always the best way to troubleshoot a system. I would encourage you to have a system, a wholesale that is dedicated solely to your TriMac Eclipse bath. These systems, all Trivalent systems, are are sensitive to impurities. So we want to make sure that we're not introducing any impurities into the hull cell, which might affect the way we were able to troubleshoot this bath. So we do recommend a 4 amp 3-minute panel be run. You do not need agitation in the hull cell. You need to have an iridium oxide anode, which is a typical anode for this process for any sulfate-based trivalent chromium process, and a bright nickel-plated cathode is utilized. Can ramp up your current, so start with 0 and over the first 5 to 10 seconds, increase that current up to 4 amps. This is what your standard hull cell should look like. So you would expect a thickness of about 0.16 to 0.3 microns with a typical coverage about 83%. And again, you can see that color is consistent all the way across. Some typical issues that you might encounter, poor coverage, and this would be really related to low conductivity salts, chrome, part D, which is one of the darkening agents, or current. Again, you can analyze for each of those and check your current, optimize them back to optimum range, which is given here, or is obviously in the TDS for each of those components. High plating speed, if your bath is plating really fast, you might have too much conductivity salts, part B or C in there. You might also have your current too high, so checking that. Again, tongs is a good way to do that. Just because the rectifier says a number doesn't mean it's actually that number, as I'm sure many of you know. So it's reducing the components can sometimes take some time. So temporarily, a peroxide add can be made to reduce that. But you need to take care in doing it, load that, and it should only be used until you can get those components to come down to their optimum concentrations. Conversely, if my plating speed is not high enough, if I'm not plating enough in the given amount of time, I again want to look at those conductivity salts in part B and part C. I also might not have enough chrome in the system. So checking that chrome concentration and bringing it up to optimum. And again, checking the current. My current could be too low and not getting enough chrome to that part. As I indicated, impurities can be an issue and can cause cosmetic defects in my Eclipse deposit. This can be introduced both by metallic contamination as well as organic contamination. You can remove metallic contamination by ion exchange, which I'll talk about in a second, or by plating out at low current density or dummy plating. Organic contamination can be filtered out with active carbon. This is an example of what resin purification equipment would look like for ion exchange, for removing those metallic impurities in the system. We do offer ion exchange equipment through MacDermid Enthone, and this is a typical system. It has 2 chambers, a PLC controller, and really helps, flush the bath through the resin. These ions are attached to the resin and removed from the system until they're saturated, and then you need to regenerate that resin. This is an example of the limits for a bright system. So a bright sulfate system, as you can see, they're very low. So resin is absolutely critical for bright technologies. When we talk about the limits for the Eclipse specifically, they are a little bit higher, but copper and zinc, no matter what the system is, whether it's bright or dark, are really detrimental. So we need to make sure that those copper and zinc layers are low, below 5 ppm. We have a little bit more room with our nickel and iron metals. So I have 2 different levels here. So if I'm really striving for excellent cast performance, I don't want that nickel or iron concentration to spike above 30 parts per million. If that's not as much of a concern, I really wouldn't want to see it go above 200. I'm going to start to see some issues with my deposit uniformity and color as those concentrations increase. So depending on what the need is, you really should keep them as low as possible. And again, ion exchange is sufficient. So even though Eclipse hasn't been around very long, it's really only been in production for the last 3 to 4 years. We do have several installations around the world. There are a handful here in the US, and we also have shops running production in Asia, in both Japan and China, and in Europe, in Spain, Germany, and the Netherlands. We've had more than 14 installations for production in the last 18 months, and to date, there are over 10,000 gallons of Eclipse in operation. And a lot of this is really because of the superior cast and Russian mud that we can get out of this finish, in addition to the luxurious dark look that it provides. We do have a patent application for this process. And as you can see, it is utilized at the OEM level and does have several approvals at this point. This is a finish on the front grille of a Lexus. It's met to Toyota specification and has a color call out of 11CR35. But Toyota is not the only one that has approved the TriMac Eclipse. Automotive OEMs in the US, Europe, and Asia have all approved the Eclipse for a finish. You see FCA and GM here in the US have Honda, Hyundai, Nexted, PSA, and Toyota, again, all have color callouts with the TriMac Eclipse finish. And it continues to gain popularity as it becomes more mainstream, and there is more production being produced, or more parts being produced with this finish. If you'd like to see our updated list of OEM approvals, you can find that on our website. You can go to industrial.mcdermidenthone.com. It does list each OEM and all of the different finishes and color callouts that we are approved for, and there are several. We are actually in the process of doing another update, and I expect that that will be done somewhere in the second quarter. But there is an extensive list on there right now with over 100 automotive OEM approvals. So I encourage you to head to the website and check those out. So in summary, we do have chrome finishes that are being produced from Trivalent Chrome electrolytes all around the world. They are in production. Eclipse, as I indicated, is in production in many facilities globally and continues to grow both here in the US and around the world. We continue to work with the OEMs, automotive specifically, on PPAPing these finishes and showing that they're viable for a variety of applications. And we utilize all of these finishes with a hexavalent chromium-free post-tip. Most widely used in this case is our Trivalent CP3000. So again, I thank you so much for your time. I hope you're all staying healthy and safe. And please enjoy the rest of your day. So much.
Chrissy, thank you very much. We have a few questions, if you don't mind to answer.
Sure.
One of the questions is, with the dosing of the additives, how is the solution volume controlled?
Sure, so this comes up a lot. I mean, and a lot of people think that with the amount of volume that's dosed in, it's not running at a super high temperature, so 109, but we haven't had any issues where we've needed to bail out or feed and bleed the system. So basically, between a little bit of the blow off from temperature and the drag out of the solution, we're able to maintain that solution level fine.
And then one other question we have is, based on our experience on metallic contamination, do we know which ones have more of an influence on getting the correct black color?
Sure. So if I talk about the Eclipse specifically, there are some metals, and this is what makes the Eclipse different than a lot of the other dark trivalents that are out there. There are some metals that are introduced into the Eclipse system to keep it dark, but we do know metals like too much iron in the Eclipse deposit will cause it to lighten up. Nickel really doesn't have as much of an effect unless it's well over 200 ppm, but really it's the iron in there that is going to lighten it up. So there's a really delicate balance that needs to happen between the metals that are in the system to maintain the dark finish and the metals that contribute to lightening that finish. We've done a lot of work with our equipment division at our current customer base to optimize the ion exchange for this system. And we have, a pretty good system that we're comfortable with that's able to maintain this system appropriately.
Okay, great. Two more just came in. The first one is, can we use a post-water rinse of hexavalent chrome? And if so, does it have any appearance impact of the final product?
So we can absolutely, there are still people that are using a hexavalent post-dip after a trivalent finish. A lot of people think that's counterintuitive because you want to make, a green or more environmentally friendly line, but it absolutely is done. I have seen a tendency, depending on the concentration of that passivate or rinse, I have seen it sometimes make that finish a little bit more yellow, which could obviously be a concern. So I would caution, you to be careful on how much chrome is in that final rinse or in that passivation step, as it could cause some slight yellowing of that deposit.
Alrighty. Another one, if our chromium layer is trivalent chrome, then why do we need the sealer on top versus having hex chrome?
Okay, so, and again, it's really just to advance that corrosion protection. And I understand that a lot of that, a lot of what I explained corrosion comes from the nickel layers. But what happens is, we really want that finish to be oxidized and hardened so that it doesn't introduce any unnecessary corrosion sites. So as I indicated, when the hex comes out, those parts come out of the bath, they automatically oxidize on their own. And we want that oxidation layer to form on the trivalent so there are no unnecessary sites for corrosion to penetrate into that nickel layer. So it's just another added layer. But we do get, obviously, because of the nickel layers underneath, we do get excellent corrosion performance without it. But it's just something that we wouldn't recommend. We always recommend utilizing a post-dip after the trivalent.
Great. Are the resin chambers and the size of the resin chambers critical for ion exchange?
So the resin chambers are critical, yes. We would size them. I think right now we typically have one size, and I can double check that, but the last couple of units that I've recommended to customers have all been the same size because we don't have any baths out there right now that are like over 10,000 gallons. Obviously, if we had a really large system, we would need to probably increase the size of those chambers. But for the size of the baths that we're seeing customers install right now, the equipment that we have can be utilized for all of them. So yes, the size of the chamber is important, but unless it was a really huge system, we wouldn't need to scale up from where we are right now.
A few more just came on the wire as we're talking.
Okay.
Any specific measurement techniques to measure the thickness of these dark chrome deposits?
Yes. So as I indicated when I compared the hex to the Eclipse, for example, the Eclipse deposit is really only 50% chrome. So if I take a Coker or X-ray measurement of that deposit, I'm not getting a true value of how thick it is. So there are factors that we have implemented, and we've done this by utilizing techniques such as GDOS or an SEM FIB instrument to really get the true thickness measurement of that deposit. If you have a really good SEM, you can do it by cross section. So you can really see, but we're talking about such thin layers. I mean, even if I'm plating, I indicated what a thick chrome deposit would be, 1/2 micron. That's hard to see unless you have an advanced SEM on site or access to one. So, but we have what we have done is we have some advanced equipment in our Orange and Langenfeld facilities that we've utilized to help us figure out the thickness of these deposits. We recommend that those factors be used, and we've also had our customers, once these processes are in production, check them against our equipment to make sure that the factors that they're utilizing are appropriate. And we do that on a somewhat regular basis. So probably every 6 months, we want to check and make sure that that factor is appropriate. But yes, it's a good point. The thickness, the way to measure thickness is going to be different depending on the system. Eclipse being the most dramatic of all of them because of the alloy percentages.
And a final one, fingerprinting. How are these black finishes affected by the fingerprints?
Fingerprints is tough. I'm not gonna lie, and it's something that we continue to work on an anti-fingerprinting solution or coating to assist with it. But yes, the dark finishes do show fingerprinting probably more than the other finishes do. Our Trilite CP3000 passivate, in addition to the corrosion protection that it helps with, also offers, I'm not going to say that it eliminates fingerprints because it doesn't, but what it does is it helps with the cleanliness. So they're able to be wiped off a lot better, and they don't get so ingrained into the deposit as they would without that passivate on top. So yes, fingerprinting is an issue. It's something that we're continue to work on. But this Trilite CP3000 post-dip does help with that.
Excellent. Well, thank you very much. It was a fantastic session. Again, for those of you we didn't get to your questions, we will follow up with you on an email. And again, thank you all for attending these sessions. It's been very informative for you. Stay safe, enjoy the rest of your day, and these sessions will be posted on our website so you can view them again. We will send out the links once they are available. Thank you very much again, everyone, and enjoy your day.
Thank you, everyone.